We continue our discussion of the binomial option pricing model with two states, and in our previous example we talked about an economy where we have, or financial markets where lending and borrowing can be done at a 10% rate. There's an underlying stock with a current price of $100 at time 0, and at time 1 the stock price can either go up or down in value, up to the level of $120 and down to the level of $90. And we also calculated that you might find a call option which is valued at $6.06, where at the up node it gives a payoff of $10, and at the down node it expires worthless. All right, so therefore we were able to exactly calculate the price, the premium, the price for this call option, which obviously has a value because the payoff is never negative. What we can do next is how can someone actually benefit, create an arbitrage if there's a mispricing of the call option. So basically, let's assume to the contrary, that assume for a moment that right now the call option in the marketplace is overpriced and it is selling at $6.50. So when that's the case, how can we create an arbitrage so that we would benefit without incurring any losses? So and the idea is the following: because it is overpriced, you want to create you want to create an arbitrage and benefit from this mispricing by simply selling these call options, right? Because it's overpriced, your arbitrage strategy is so let's write that down. Arbitrage strategy is based on selling these selling these call options, or writing call options, writing C's. Okay, so and to be exact, here is what we have. We will preserve the delta hedging ratio, so we will be writing, so write 3 calls, and we will again purchase. To counter that, we will purchase 1 stock, and lastly we will also borrow some money. Well, we want to borrow just the amount which will make the cost of this portfolio, of this arbitrage portfolio, equal to 0. So how much should I borrow that will make the cost down to 0? So we can easily calculate the cost of each component. So the cost of this one would be of writing 3 calls would be negative 3 times 650, or 3 times negative 650, right? Why is that? Why negative 650? Because we are writing the call options. It's not a cost, it is a revenue for us, so it's a negative cost. And then the cost of purchasing 1 stock is obviously $100, because the stock is currently selling at $100. And finally, because we are borrowing, again, this is a revenue, so that's a minus X. So we want to add these 3 numbers, and we want the final outcome to be 0. So we want to build a portfolio which we claim is costing the arbitrager nothing, right? And so if you solve this, so therefore we have 3 times minus 6.50 plus buy the stock for 100 minus X is equal to 0, implying that minus 1950 plus 100 minus X is equal to 0. Finally, X, which is the amount that we are going to borrow, is equal to 100 minus 1950. It is $80.50. So we're going to go ahead and borrow $80.50 while creating this arbitrage portfolio. And let's see what will be the outcome of this arbitrage strategy. Let's call this portfolio as A again. So this arbitrage strategy portfolio, or maybe AS, let's call it AS, arbitrage strategy. So arbitrage strategy portfolio will be worth how much in the following period. So AS would be, we have two options, two states of the world. In the up state, where the stock price goes up in value and the call option expires in the money, and the down state where the stock price goes down in value and the call option expires worthless. Okay, so in the up state, because we wrote three call options, starting with the first one, each one will cost us $10, so minus $30, plus, well, we purchased one stock, so that will give us a payoff of $100. And because we borrowed X dollars, $80.50, we need to pay it back with its interest. And so this amount with its interest, pay back. How much are we paying back in year one? We are paying back the X plus R times X, the interest amount as well. So it is 1 plus R, which is 1.10, times X, which is $80.50. So we know that if we borrow at time 0, $80.50, we need to pay back $88.55. So that's the amount that we will have to pay back at the upstate, and the difference would be equal to what? Would be equal to wait a second. This is not true. In the upstate, the stock is giving us $120. Sorry for that. So 90 minus 88.5. So that's equal to plus $1.45 in the upstate. So we are profiting in the upstates. Let's check the downstate. In the downstate, the call option goes worthless, and it's a happy news for us because we wrote the call option. So plus the stock expired at $90, and minus we still have to pay that $88.55. As a result, again, guess what? This is $1.45. So we basically created an arbitrage here, right? So look at that. So we started with a cost of $0. Cost was, we built a portfolio whose initial cost at time 0 was $0, and then at time 1 we construct our portfolio earned us $1.45. So we basically created profit out of nothing. So that's pretty good. And by simply multiplying this portfolio 1,000 times, for instance, we could have made $1,450. Or if you multiplied this portfolio 1,000,000 times, then you can see how these things would have multiplied as well. So we have created our arbitrage strategy is based on a portfolio with an initial investment of 0, and yet 1 year later a positive profit, no risk involved, because in both upstate and downstate we are getting the same number. No risk involved, positive profit. Let's write all this down. So therefore initial investment equals $0, and then year one return is equal to $1.45, which is obviously greater than 0, without risk, without any risk. That's amazing. So and that's it. So we created this arbitraging. So therefore the mispricing will be causing a lot of arbitrage people to make this strategy. A lot of people will start selling this, writing these call options, and over time it will obviously drive the call price down because there's an excess supply, and that will drive down the prices. But one more thing before I wrap up this example is that this $1.45, when you discount it to the present amount, the present value, the present value of $1.45 at year one is equal to $1.45 divided by 1.10, and if you do that, you would get I believe $1.32. $1.32. Now what is strange about this is exactly equal to 3 times 44 cents. And let me give you a minute to pause this. I would recommend you pause the video right now. Try to see what is the significance of this 44 cents. If you already figured this, then you have a really good, you followed up the video carefully. Well, assuming that you guys already paused it, the 44 cent is the amount of mispricing of C. Notice that currently the option is selling at $6.50, but it was supposed to sell, the fair price was $6.06, and that's exactly equal to 44 cents. So what it tells us that this $1.32 present value is directly equal to 3 times the call that we wrote, right? So as a result, so this again shows us that this 44 cent present value profit per call option, obviously, that we can make. And by writing 3 calls here, of course we knew from the beginning that we would make $1.32 present value, and in year one that's equivalent to $1.45. All that was left is to somehow intelligently construct this nice arbitrage portfolio. Now I want to reverse the problem now, and in the second part I want to ask you guys, what happens if the call price was underpriced? Actually, if instead of $6.50, what if it was $5.50? So let's open a new page here, and if it was, and let me change the color of my marker, so if it was $5.50, so let there be a mispricing in the call, and instead the call was selling at $5.50 instead of $6.06, or the $6.50, the previous example. So if this was the case, obviously because the call option is underpriced, it's so cheap now, right? Of course I want to purchase as many as I could, so this way, so therefore my arbitrage strategy will be based on that. So therefore arbitrage strategy will be based on, because it is so cheap, it is underpriced, it is based on purchasing the call options. And let's go ahead and do that. When we purchase these call options, we will keep the same delta ratio. So we will purchase 3 call options and we will sell 1 stock. If we don't own it, we will just short sell it, right? So let's go ahead and create this arbitrage. So therefore this would imply that the arbitrage strategy would be pretty much the opposite of what we did in the previous step, in the previous example. So we are purchasing, buying 3 options. So buy 3 call options, and what else? We short sell 1 stock. So still the ratio is equal to the delta hedge ratio, 1-to-3 ratio. And finally we will lend money. So we should lend X dollars in such a way that the overall cost of this at time 0 should be equal to 0 again, just along the same lines as the way we created the previous one. So when we buy 3 call options, that would be costing us 3 times $5.50, and that's a total of $16.50. Short selling 1 stock, we will benefit yeah, so this is the cost. Short selling 1 stock will cost us well, will benefit us minus $100. Obviously it doesn't have a cost because you are selling it. It's a revenue, it's a minus cost. And finally, because you are landing we are landing X dollars, it has a cost, and that cost is X, like it said. So the total of these three better be equal to 0. So therefore, going back to this side, we have 1650 minus 100 plus X better be equal to 0. So therefore the initial investment is exactly $0, hopefully. So X is equal to 100 minus 1650, and that should be $83.50. So therefore we will go ahead by landing $83.50. So this is the landing. That's it. So let's now check what will be the outcome of this at time 1. So therefore the arbitrage strategy at time 1, well, at the up or down state we will have two different outcomes. Let me change the market color actually. So we will have two different results. Well, first of all, at the up state, so we purchased 3 call options. The calls will expire in the money, so therefore we will make $30 benefit. Well, we sold one stock. We need to buy it back. At the up state, it will cost us $120, so it's a negative revenue. And finally, we did land X dollars, $83.50 early on, and as a result, we will get back this money with its interest. So if you do $83 and get back at year 1, how much are we getting back? 83.50 times 1.1, and if you do the math, that should come out as $91.85. All right, so therefore we are getting back $91.85. So therefore at the up state, the difference here is minus 90, so that's just $1.85. So that's a profit. That's good. Remember that the initial investment was exactly 0, right? So perfect. But anyhow, at the down state, the call option goes worthless. The stock, I need to replace it, so put it back. So it will cost me $90 to replace it. And finally, I will make $91.85 from the landing activity. So they pay me back the money with its interest. But guess what? This is again $1.85 payoff. So therefore, without risk, I have sure $1.85 gain. That's a sure gain. That's amazing. Okay, so as a result, I created an arbitrage again. So we made $1.85 out of nothing. And just the way we concluded in the previous example, you might wonder that $1.85 where it comes from. So per option, how much? First we can get the discount at $1.85, the present value. So therefore, the present value of this $1.85 at year 1, the present value of it as of year 0, obviously, is equal to $1.85 divided by 1.10. And that would be simply equal to, let me tell you, 1.85 divided by 1.1, $1.68. But wait, this is as a result of buying 3 call options. So therefore, per call option, how much gain did we have then? The profit is the arbitrage profit, if you will, is equal to $1.68 divided by 3, and that should be divided by 3 equals 56 cents. 0.56. Now that's, what do you think this number reflects? Just the way we did it in the previous example, this reflects the mispricing. Obviously, it was supposed to be selling at, the call options were supposed to be selling at $6.06. Instead, they were selling at $5.50. So there was a 56 cents mispricing, and obviously the way you constructed this portfolio AS, you are able to capture all this mispricing and to your advantage as a gain in the following period. So that's how powerful these strategies can get, these arbitrage strategies, in making to summarize, in this situation, the initial investment was $0, as we proved here. These were the costs of each of the three components of our portfolio AS. So with a zero initial investment, I was able to get $1.85 sure gain. And that's just out of nothing, basically, right? And that's it. So therefore the arbitrage strategy worked. And when we looked at the pricing, the per share gain, I should say, call option gain was 56 cents in today's amount, and that's exactly equal to the mispricing of the call option. So and that's it. So this shows you the power of arbitrage strategy. But thanks to this arbitrage strategy, that's what makes the prices the law of one price work, and that's what makes the pricing of securities bring those pricing to their fair values, actually. So the market, if you let it work, it would eventually get the corrections, and the call options will be sold at their fair values. And in the next part, in part 3, we'll go ahead and this one period binomial option pricing model, we will make it into a multi-period, into a 2 and eventually 3 period, extend the model to 3 period binomial option pricing. And as such, not only European options, but we will also be able to value American options as well, where you can actually price, you can actually exercise your option before maturity, before expiration. All right, see you guys in the next lecture.